Lesson 8-4, Extending Line Symmetry. In this lesson, I want you to be able to identify objects with multiple lines of symmetry. I want you to create shapes with a specific number of lines of symmetry. And finally, for you to find the lines of symmetry in quilting patterns and design your own quilt pattern. But first, let's start with our mental math and fluency. Write the decimal equivalent to these fractions. 41 hundredths. This should be easy for you by now. 0.41. The last number, the number 41, the 1, ends in the hundredth spot. 93 hundredths, again, 0.93. And 84 hundredths, 0.84. I want you to look around the room and find an object that has at least 2 lines of symmetry. Write the name of the object and record the number of lines of symmetry it has on a slip of paper, and then bring it up to me. Pause the recording now and please do that. Some of you brought up a rectangle and you said that that rectangle had 2 lines of symmetry. And you were right. You could cut it in half, and this side to the left would lay exactly perfectly on this side to the right. Another line of symmetry that you found was to go the horizontal way. The top part of your rectangle would lay perfectly on the bottom part. Some of you found posters that were perfect squares, and you found that you could do multiple lines of symmetry. You could cut it down to the middle. You could cut it horizontally. You could cut it from corner to corner and corner to corner. Here again, that's if the lines are perfectly the exact same measurement and make a perfect square. Someone else noticed that there was a rectangle, and they said it had 1 line of symmetry, and they were correct on that. The line of symmetry went directly down the middle, and the left side would land exactly on the right side. So, some questions you should have thought about is, how do you know this object has a line of symmetry? Remember, 1/2 of the objects is like a mirror image of the other half. If you fold the object across the line of symmetry, the parts would match perfectly. Are the lines of symmetry in your shape vertical, horizontal, or diagonal? Well, some of you found that it could be vertical and horizontal. And as in the square, you found that it was vertical, horizontal, and diagonal. But with the triangle, it was just vertical. And finally, what do you notice about the objects with multiple lines of symmetry? Well, remember, the poster that's shaped like a hexagon has 6 sides and 6 lines of symmetry. A polygon with sides of equal length have the same number of lines of symmetry as sides. Take a look at the squares shown on the screen. Look at how they all look somewhat similar. If all of these squares show the same pattern, why do they have different numbers of lines of symmetry? So what they're showing you here is this one has 4 lines. 1 vertical, 1 horizontal, and then 2 diagonally. But yet this one that's shaped very much the same only has 1 horizontally and vertically. And yet again, this one only has 1 vertically. And here yet still has none. I want you to pay close attention to this. What's making the difference is the shaded in area. If I would cut this one down through the middle, like it already has a dotted line, this lightly shaded gray would land right on top of this lightly shaded gray. All of this that's the darker gray would land perfectly on this that's darker gray. Again, this lighted shaded gray would land on top of this one, and the white triangles would fall neatly right on top of each other. The same if I would do it, and I'm going to have to erase here real quick so I can show you yet again, if I did it horizontally. Horizontally is looking at the line that is going this way. This gray part would land perfectly on this gray part. When I folded this down, this white part would land on this white part. Again, this gray part on this gray, and the same for this side. This darker gray would land on this darker gray, and the white would land on the white. For this one, the reason it only will work vertically is because of this gray triangle. In order for this to fold over, this gray would have to land on there. So if I tried to cut it this way, these two gray pieces would not land on these two white pieces. These would have to be gray. So that's why it will only work vertically. And this one can't work either way. Look, if I cut it down vertically, I have white trying to lay on gray. Well, that automatically told me that wasn't going to work. Or if I try to do it horizontally, again, this dark gray would land on top of this white. If I try to do it diagonally, again, this gray flipped over here would not even land right here. It would land differently. So that's why this one has none. So you can't assume just by looking at it and trying to answer this too quickly that just because they have similar shapes that they will have similar answers for symmetry. So on Math Journal page 280, you should be looking at what I just showed you. The lines of symmetry for this pinwheel pattern was 4. For this one, because of the shading, it was 2. Again, because of this one with the shading of gray, it was only 1. And for this final one, it is 0. What I would like you to do next is to work on Math Journal page 280 and then bring it up to me because this is a math assessment check-in, an ACI. I want you, it says this is called a bow tie pattern. All 4 of these are. How many lines of symmetry do you find in the first one, and the second, and the third, and in the fourth? Then go on to the Ohio star pattern and do the same thing. Remember, you're looking for lines of symmetry. If you need to, go back to the top and look how they cut theirs in half, first vertically, then horizontally, and then diagonally. Do that for each of these and you'll be able to find your answers fairly quickly. The third one says it's the pineapple log cabin pattern. Again, look for lines of symmetry, and that is it. So pause the recording now, do Math Journal page 280, and then bring it up to me so I can mark it off as your ACI. After I've checked Math Journal page 280, I want you to go to Math Journal page 281. Read this to yourself as I read it out loud. It says, some patterns, called 9-patch patterns, look like they're made up of 9 squares. You can make your own 9-patch pattern on a 3x3 grid. So go to the file and take out Math Masters page 307 and 308. Color 6 squares on Math Masters page 307. In one color and the other 6 in a different color. Cut out the 12 squares. Then make triangles by cutting 6 of the squares in half along a diagonal. Make rectangles by cutting the other 6 squares in half along a line through the middle. So as you're doing these, do it one direction at a time. First, get out your Math Master pages 307, 308 and color 6 squares on page 307 in one color. Pause the recording and do that. If you have the recording back on, then you need to take the other 6 and color that in a different color. Pause the recording again. Then cut out the 12 squares. You should have paused the recording. Now I want you to make triangles by cutting 6 of the squares in half along a diagonal line. So you're going to cut them like this. Pause the recording and do that instruction. Make rectangles by cutting the other 6 squares in half along a line through the middle, like shown here. If you're following and going along with my instructions, then you must have done everything I just asked you to here. So now you need to arrange some of the pieces on this grid on Math Masters page 308 to make a pattern. Follow the directions below. When you have completed a pattern, draw and color it on one of the 3x3 grids below. So it says make 1 or 2 patterns having 4 lines of symmetry. You're going to do that here. Then you're going to make 1 or 2 patterns that only have 2 lines of symmetry. And you're going to do that here. And finally, you're going to make 1 or 2 patterns having no lines of symmetry. And you will do that here. Pause the recording now and then bring it up to me when you've finished it, because there won't be an answer in the Math Journal answer key because there will be so many varying answers for this problem. So pause the recording now and finish this page and bring it to me when you have completed it. Once you've completed doing that for quilting patterns, I want you to go to Math Journal page 282. Read this to yourself as I read it out loud, and it says, estimate your answers before solving and use your estimates to check that your answers are reasonable. So 8 baseball teams are participating in a tournament. Each team is bringing 18 players and 2 family members per player. All are traveling in vans with 7 people per van. How many vans are needed to transport all of the players and family members? So I'm going to walk through this first one with you. So my number model says there are 18 players and 2 family members per player. So I'm going to do, 18 players times 2 family members per player. All are traveling in vans with 7 people per van. I'm sorry, let me stop here a second. And there's 8 baseball teams participating in the tournament. So I'm going to do this times 8. All are traveling in vans with 7 people per van. So then I'm going to divide, once I figure all of this out, by 7. And it says I have to have an unknown. It's asking me how many vans, so I'm going to leave my unknown for vans at V. This is how you would first do this number model. Now to estimate that, I would just simply round 18 to 20, and I would leave it times 2, which would give me 40. Then I would take 40 and I'm going to round 8 to 10 times 10, which would give me 400. And then I'm going to divide by 10, which gives me approximately an estimate of 40 vans. So what's my real answer? Well, 18 times 2 is 36. 36 times 8, well, I'm going to come over here to the side and do that. 36 times 8, 8 times 6 is 48, carry a 4, is 288. Then it says I need to divide that by 7. So I'm going to partial quotient this and divide it by 7. 7 will go into 288. Well, 7 will go into 28 4 times, so I'm going to do 40. 0 times 7 is 0. 4 times 7 is 28. And then again, I subtract. I divide again. 7 will go into 8 once. 1 times 7 is 7. I have 1 remainder. So how many vans will it take? It will take more than 40, 1, because I cannot leave 1 person behind. So it's going to take 42 vans. What did you do with any remainders you found? Well, with the one